Hey everybody, and welcome to sections 12.5 and 12.6 of chapter 12. So 12.5 deals with prediction. So remember this example that we've been just milking this whole chapter. So basically when we went, we discovered that the correlation coefficient was significant, right? And we found the best fit line, and it had this equation right here. Okay, so now that we've proved it to be significant, we found it significant, we've showed it significant, and we have a line, we can now begin to estimate or predict the mean final exam score of stats students who receive 73 on the third exam. So as long as it falls within the interval, or at least close to, then we can use it to predict. Okay, so the exam scores range from 65 to 75. And since it's between, we can use it in our equation here of our line. So we just plug in 73 and work that out, and you get y hat equals 179.08. So then you can say we predict that statistics students who earn a grade of 73 on the third exam will earn a grade of 179.08 on the final exam on average. So what would you predict the final exam score to be for a student who scores a 66 on the third exam? So what would you have to do to that? And it's in the range, right? So if we plug it into the into here, we get 145.27. And what would we predict for somebody who got a 90 on the third exam? So 90 actually is a little difficult because it's outside of the domain, right? It's outside of the X values data that we collected. So we really cannot predict the final exam score for the student. I mean, you could plug in 90. Nobody's stopping you from doing that, but it won't necessarily be as reliable as the other if it were to fall in the correct interval. So let's see, for example, so let's try it. So we plug it in here, and then we get 261.19, but that doesn't make any sense because the largest you can get is 200. So, okay, so that's 12.5, nice. 12.6 deals with outliers. Okay, so remember we talked about outliers before. You know, there are observed data points that are above the far from the least square line, so they have really large errors. Okay, so the rule of thumb is basically any point that's located further than 2 standard deviations above or below the best fit line is considered an outlier. So how can you do this visually? You can do this visually by drawing an extra pair of lines. So you take your line and then you add 2 standard deviations to it and draw another one, and subtract 2 standard deviations from it, and then you have a third one. And so basically you can calculate the standard deviation, and then you can plug into y1 and y2 and y3 the difference and the sum once you add 2 times the standard deviation and subtract 2 times the standard deviation. So let's look at it here. So we have our data, right? We go to Lin-Reg t-test because that's going to give us our S, our sample standard deviation. So you hit there, yep, we have all of this, we know this. Okay, we hit calculate, and there you go. And then you see the 16.4, and that was the R, and that's the R squared also, but 16.4 is what we care about. Then we're going to go back to the y equals, and we're going to basically use the line of best fit, but then we're just going to add and subtract 2 standard deviations. So you just do the same line, and then minus 2 times 16.4 for y2, and then plus 2 times 16.4 for y3. Okay? So when you hit graph, you'll see it. You'll see the lines here, and you see the outlier right there, or the suspicious one, right? Okay, so we can do this numerically as well. However, you know, if you really want to put yourself through that, sure, go ahead. It's detailed very nicely in your textbook. But I think for now, I think I want you guys to just be able to do it graphically. But I mean, if you want to go ahead and try it the other way, by all means, send me any questions that you might have about that. Okay, so we've identified this point as an outlier. So now what? We found an outlier, now what? Okay, so it's right outside, it's right above 2 standard deviations away from the line of best fit. So let's look at the data again. So if this was to happen in real life, we look at the data and see if there was any problems, like if there was an error when we collected the data, or if we can fix it, or ultimately we could delete the data. But if the data is correct, we'd leave it. Okay, so let's suppose in this problem we examine the data and we found that this outlier was an error. So what we'll do now is we'll go ahead and delete the outlier so we can see how it changes the results. Okay, so we're going to go ahead and do that. So we do stat, edit, enter, and then see this is the troublemaker on the top, so I'm just going to delete from L1 and L2. Okay, now I'm going to have that, and I'm going to go ahead and calculate everything anew with the linear regression t-test. And then enter. And then the same thing, same settings. Except remember, you do want to put it into Y1. So just y vars function, enter, and then calculate, and we will see what we get. So there it is. So now our A is 355.19 and our B is 7.39. So it changes things. And our R is 0.9121. So it's actually a stronger correlation, yeah, which makes sense because you got rid of this outlier. It's closer to 1, so it's pretty strong. So now this means that this line can better predict the final exam score given the third exam score. And see how it changed? It changed the line. Pretty crazy. Okay, so let's see here. So if we want to use this new line of best fit, what would a student who receives a 73 on the third exam expect to receive on the final? Is that the same as the prediction made using the original line? So if we use a new line of best fit, and it's not going to be because it's a different line, yeah? So we plug in 73 to the new one and you would get 184.28. So now we can say a student who scored 73 points on the third exam would expect to earn 184 points on the final. And then the original line predicted 179.08. So the new line is different from the original. Okay, so that's really all I have for 12.5 and 12.6. So your super fun homework is no homework. Use this time, please, to study for your last exams. It's been a pleasure working with you on this course. Thank you so much for making it this far. Congratulations and good luck, and I will see you in class. You got this.